Due to issues with Bluetooth in our project, we've decided to use wired connection between two EV3 microcontrollers in the same humanoid robot. As you can see here, the first EV3 connected to the PC is called the main EV3. It is the one which executes all of the code. To the first EV3, we can see through a PC cable is connected to a second EV3. Here the second EV3 does not have any code and is directly receiving signals from the first one. It is known as a subordinate EV3. In programming, to run the motor lines of the main EV3, we use the first layer, and to control the motor lines of the subordinate EV3, we use the second layer.
We are using master-slave Bluetooth communication to initiate the performance. As soon as the song starts, the sound sensor picks it up and sends the signal to all other robots, starting the career.
This is the main humanoid robot. In this, as explained in the daisy chain part, this is the main processor and this is the subordinate one. Now initially we had a lot of issues with not having enough clearance between the arms and the main body. So what we did, we used a lot of box connectors with more box connectors on top to help reinforce it. We also had issues where the arm that we initially used only a small medium motor, but the gear was slipping and we do not have the exact gearing ratio. So we changed it to a large motor where it now moves freely and smoothly.
Next I'm going to explain about the cabling issues and the two-wheel drive. Initially we had used only two motors in the bottom, but this was an issue as they weren't generating enough torque to move the whole thing. To combat this, we used four-wheel drive instead and it solved our problems. Next is the cabling. In this, cabling was a huge issue as originally the EV3 was upside down, making our connections up here. We had a shortage of long wires and thus we were having trouble practicing and testing it out. So to combat this, we have flipped the EV3 around to make the connection from the top to the bottom, making us only require shorter wires.
So like this is the LED part, it's not too hi-fi. So this is our supporting robots on which LEDs are stuck, and one of the LEDs I have taken it out just for you on a breadboard to explain how it works. The Arduino is right here along with the breadboard with all the connections. Now initially we didn't have enough amperage to like supply the entire LED, so what we did, we used these power banks, one for each LED panel. One panel consists of 3 strips and each strip consists of 11 or 9 LED strips depending on the size. So we faced a lot of issues getting the amps right, that now we have figured that out. We also had to like think of a way to connect them in parallel, because when we connect in parallel the amps increases but the voltage remains the same because the potential difference is same across the both ends. So now I'll just show you a demonstrate one, and lo and behold, the Indian tricolor comes up in a pattern. This pattern repeats itself whenever it hears any new sound, and there are also several other patterns including this one. And this one. So these are the patterns which you have done now. Thank you very much.
Humanoid robots will be doing Indian dances. This consists of Bhangra, Woman and beginner South Indian dances. Indian dances are usually very complex, so we have done our best to showcase the rich heritage of our country in a 2-minute performance. Since the dances are so complex, we have made sure that humanoid robots will be able to do it safely. Thank you.
The supporting robots have been choreographed in such a way that they complement the humanoid robots' dances. These dances have been inspired from many Indian dances such as Bhangra, Woman